Suppose we wish to generate a normal probability plot. This can be done on the calculator. I will demonstrate a few examples here to show all the capabilities of this command. First, we need a list of data, and I shall generate a list of random values to expedite the construction. So I will go under Stat and Enter, and I will select L1, and what I will do is I will go under the List command and select the Sequence command under Ops. And then I will go ahead and select PRB under Math to get a random value. And I want to generate 30 random numbers. So now I have my 30 random numbers to correspond to my data list. And now I can begin constructing the normal probability plot. So I go second y equals to activate stat plots. Turn the first one on, and then I'm going to select the very last option under type, and this is the normal probability plot. Now when I select this, I can do the plot in two ways. I can put the data axis on the x-axis, or I can put the data axis on the y-axis. Now my data list is stored in L1, and I will go ahead and use the x-axis to correspond to my data axis first, and the points will be displayed by a box. So we go through and make sure all of these are correct. We can hit zoom 9 for zoom stat to size up our window, and we get our normal probability plot. If we hit the trace button, we can see the data values from the list and the z-scores associated with these data values. So I'll go ahead and hit trace, and I'll just move the cursor key around to show the data value and the z-score associated with that data value. Okay. Because this plot has tail ends that seem to go vertical, we can assume that this does not correspond to a normal density. The data does not seem to come from a normal distribution. And this is actually indeed the case. I chose random numbers from a uniform or a rectangular distribution rather than a normal distribution. So it makes sense that I would see this kind of behavior from this list. Now let's examine the graph when the y-axis is chosen as the data axis. So we'll go back under stat plots, go back under the first one, and this time we'll simply scroll down to the data axis and select y. And then we will resize our window using zoom stat. And here we have the previous picture reflected over the line y equal x. And again, I have switched the roles of x and y when I select the y-axis as the data axis. And hitting the trace button again reveals this. The data values are here as y. The z-scores associated with these data values are listed in x. Now the x values in the z-score are the z-scores and the y values are the actual data values. So let's examine a normal probability plot with data that actually does come from a normal distribution. So we can see what one should be looking for when we do have this behavior. So we'll go under Stat and Edit. We'll go ahead and select L1. And again, we'll generate a sequence of random numbers. So we'll go under List, Ops, and select the Sequence command. And this time I'm going to go under Math, and I'm going to select PRB. But now I'm going to select Rand Norm. This is going to generate random numbers from a normal density. And I'll go ahead and choose a standard normal density. So it has a mean of 0 and a standard deviation of 1. And I'm going to generate 30 of these values. So we'll go back under stat plots, and we will go ahead and choose the data axis as the x-axis, and we'll go ahead and zoom 9. In this way, we see that the data values tend to follow a straight line more so. And when we observe this straight line behavior under a normal probability plot, we can be confident that the data in fact do come from a normal distribution. And this is how you can generate and analyze a set of data and a normal probability plot on the calculator.